King comes to help to solve this integral. Okay, we have the integral from 0 to pi by 4 sine x plus cos x over 9 plus 16 sine 2x dx. If you try to approach this integral in a straightforward way, like you might get some pause and you might not be able to solve it, though you can. But using King's rule for this integral makes it a lot easier. It just saves our life. Okay, so before we begin, let me tell you what King's rule is. King's rule states that integral from a to b f of x dx is equals to integral from a to b f of a plus b minus x dx. Okay, so to see why this works, you might just see it visually, or you can just also integrate it. If you want to just integrate it, let's see if this is uh, f of x, where this f of x is the derivative of this, and a to b. So we get capital F of b minus capital F of a. Okay, and if we use this thing, we get capital F of a plus b minus x by minus 1 from a to b. So this gives us negative 1. Let's take it out, and then we get f of a. Yeah, if it would be f of a minus f of b. Okay, so and just multiply by minus 1, you get the required result. Or if you want to see it geometrically, also it's just we first have f of x. We first have f of x, and then we reflect it on y-axis to get f minus x, and then shift by a plus b to get it f of a plus b minus x. And using this transformation, you can just see how it actually works. I guess this algebraic proof is okay for you to convince that this King's rule is true. Now let's move to the problem. Okay, so if we use King's rule, we get something like 0 to pi by 4 sine of pi by 4 plus 0 minus x, that is pi of minus x, sine of pi of minus x plus cos of pi by 4 minus x by 9 plus 16 times sine of 2 times pi by 4 minus x, that is pi by 2 minus 2x. Okay, and dx. Now you might see why this helps, because with this change of I guess variable or anything what you can say, this helps us to simplify the numerator. If you just want to take a look, this is sine a cos b. You can just use the formula sine a cos b minus cos a sine b plus cos a cos b plus sine a sine b. Yeah, now this to get cancelled out, so that's how it helps. But before going to that, let's write the numerator. 9 plus 16 cos 2x dx. Okay, so we have progressed a lot in these 2 steps, since it's a lot easier now. Integral from 0 to pi by 4. We have root 2 cos x over 9 plus 16 times. Since here is cos x dx, we'll try to make it in terms of sine. So we get 1 minus cos 2x is 2 sin square x. So 1 minus 2 sin square x. Okay. Now we'll try to let y as sin x, since we have cos x dx here. With that we have integral from 0 to pi 0 to I guess sine pi by 4 is 1 by root 2, and we have root 2 dy by 25 minus 32 y square. Now we can do some formula of integrals. If we have dx by a square minus b square y square, we can just use the formula. We have 1 by 2a ln of a plus by by a minus by dot 1 by b. You can just use this formula to simplify it now. Okay, let's take root 2 out, and then we have 1 by 2 times 5, since 25 is the square over here. 1 by 2a, ln of 5 plus root 32y by 5 minus root 32y times 1 by root 32, and we evaluate it from 0 to 1 by root 2. So if you just evaluate it, it's not that tough. We can go like this. We have root 2 by 10 times root 32, and ln of 5 plus this will be root 16, that is 4. 5 plus 4 by 5 minus 4 minus ln of 5 by 5. Yeah, since we put 0, we get ln of 5 by 5. And then we have, this one is 1 by 40, ln of 9, yeah, minus ln of 1 is 0. So this is 3 square, so we get 2 times ln of 3 by 40, and then ln of 3 by 20 is our answer. Ln of 3 by 20 is the answer. So we can clearly see how easy this integral became by using King's rule, because it simplified the numerator. So solve this integral, and the answer is ln of 3 by 20. So just keep on using the King's rule wherever you can. It might save your life sometimes. Thanks for watching.